Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay. So the problem given is this reaction with 1 mole of SiO2 per 3 moles carbon reacts to become 1 mole of SiC, 2 moles of carbon monoxide. So what they want is to find the amount of moles of the 3 missing products or reactants given one amount. And they want to assume that we are making this reaction as efficient as possible, meaning that we're not using excess reactants here. So, for example, if you wanted to make, for this third line, 10 moles of carbon monoxide, you could just dump in, 100 moles of all of this, but that would not be as efficient. So what you're going to want to look at when approaching this problem is the ratios for the equation. So remember our equation here. We have these coefficients of 1 for SiO2. We have 1 for SiO2, 3 for carbon, 1 for SiC, and 2 for carbon monoxide. So you can use these coefficient ratios and notice that SiO2 and SiC will always be the same. So if you're given one of those two, you can just immediately plug the same number of moles in. For the carbon and the carbon monoxide, it is as simple. You'll have to find a relationship between those in order to determine the amount of moles of those. So, like I said, you use those ratios. You can develop equations to find moles of any products or reactants, one of the products or reactants. So if we let X equal the moles of SiO2, which is going to be the same as SiC, and then Y can be moles of carbon, Z can be moles of carbon. So we can look at the coefficients here. Carbon is going to always have 3 times as many, or require 3 times as many moles as SiO2 or SiC, and therefore Y, moles of carbon, will always be 3 times. The X value can also be written, if you divide both sides by 3, X will be Y over 3. Similarly, carbon monoxide is always going to have twice as many as SiC or SiO2. So Z will be 2 times X. Divide by 2, you get X equals Z over 2. And lastly, the coefficients of 3 carbons to 2 carbon monoxides, we'll look at like Y equals 3 Z over 2. So an example here, we're given 3 moles of SiO2 for the first box here in this problem. So we get X equals 3, so we can plug in these two immediately. X equals 3 is going to be the same as this SiC over here. And then moles of carbon and carbon monoxide. Y carbon is going to be 3 times 3, will be 9. And carbon monoxide will be 2 times 3, will be 6. So here we will get 9, and here 6. Okay. For the second, moles of carbon, which is what we defined as our Y value. So I've put the equations over here to kind of make it a little easier. So if Y equals 6, then 6 equals 3x. So we have 6 equals 3x. Then we'll get that x will equal 2. So both of these two will be 2. And then our relation for z right here is 2y over 3. So our y is going to be 6. So 2 times 6 will be 12. Divided by 3 will give us 4 for this. All right, so you just kind of continue plugging these numbers into these equations depending on what you're given. So if we're given this time, we're given z is equal to 10, we can first find x using our equation z equals 2x. Will give us x equals 5. So we can plug those in here. And once we have x equals 5, we can find y, because y will be 3 times x, so 3 times 5 is going to be 15. 15. Okay, here they've thrown in, looks like some decimals. This is 1.8 for the last one. 0.8. So here they give us x, in this case SiO2 is 2.8. So to find y, we will take 3 times 2.8, plug it into a calculator, and you get 8.4. And for z, you can just do 2 times 2.8, plug that into a calculator, you get 5.6. All right, and then finally, they give us y is equal to 1.8. So we can first find x if we want. If we use our very first equation, we will get 1.8 equals 3x. So 1.8 divided by 3 will give us x of 0.6. And then we can plug that in to find z. Z will be 2 times x. 2 times 0.6 is 1.2. And that will complete the problem.